Alright, so this is going to be a video about functions. And basically, functions are the backbone of what algebra is all about. Now, if you remember from the previous video, algebra is all about relationships. It's how one variable is related to another variable. And generally speaking, it's how x is related to y. So how some x variable is related to some y variable. Now, when x and y are put together with a comma between them and parentheses on the outside of them, it's called an ordered pair. So this would be an ordered pair here. Now, these x and y's would have numbers in this. So it'd be like -1, 2, or 1, 3, or 7, 2. It would be something like that for these ordered pairs. Now, how functions are related to ordered pairs is the following. Ordered pairs make up what is called relations. So this is this relation. If you remember, algebra is all about relationships. So these are actually called relations because it's how two variables are related to each other. Now, functions are basically a special kind of relation in which each x has only one y value. So anytime you have an x, there's only one specific y value that is linked to or is related to that x. You could, if you put a -3 in here for x and you get a 1 out for y, you will always get a 1 out if you put a -3 in for x. So that's how they're always related. If you put a -3 in here and you don't get 1, you get like 3 or something like that, or 4, then it would not be a function because it should always be the same value. If you plug -3 in, you should always get the same number out. If you plug -2 in, you'll always get the same number out. Okay, so that's basically what a function is. Each x only has one y value. If you plug in an x, it's only related to 1 and only one y. Okay, the vertical line test is a way for testing this fact out. If each x only has one y, you should be able to take a vertical line, so you can use your pencil or a pen, and you should be able to drape it across the function. So this red right here would be considered this relation right here. The vertical line should only hit one value. Okay, so if I did that right here, if you notice, if I put it right over here, this x value, let's just say it's 3, it would have a value here for y and a value here for y. So this would not be considered a function, it would be considered a relation. Okay? So there's ordered pairs clearly in this, but it doesn't follow the special stipulation to be a function in which each x only has one y. Okay? This blue one right here, though, if you did a vertical line test, it would only intersect one point each time as you went through that graph. So because of that, this would be considered a function and this wouldn't, because again, each x can only have one y. Okay? The x is independent, it's considered independent, it could just be any value, it's based on whatever the user is choosing. A lot of times it's viewed as time or other things we're going to talk about in a little bit later, but x is usually viewed as independent where y is dependent, meaning it's dependent on x. So you have to use a specific x value and then you'll get a specific y value out. So it's like whatever you choose for this value, this depends on that. So y is always going to depend on x. We're going to talk about more about that later as well. Okay, so because of this, x is usually viewed as the input, while y is considered the output. So I wrote right here, input and output. So x is the input, y is the output. Okay. Next thing we're going to talk about is function notation. So we have function notation right here. It says f parentheses x equals question mark. Now the reason I wrote that is just a very bare bones look at what functions are. Well, to pronounce this in actual English, instead of saying f parentheses x, you would say f of x. Okay, and it's really important to note that this f is not times x, even though it's parentheses, and you would think, okay, normally that's multiplication. They kind of doubled over in the math language here, where now the parentheses also means whatever's the input of this function. Okay, so this f represents the function name. If you want to think of this f of x, again, that's how you say it, is f of x. If you want to think of it as y, it's basically the exact same thing. This represents y, so it's just a very fancy way of writing y, f of x. Okay. X is the input, and it's inputted into this function, and this f is just a function name. And whatever you input this in as a function right here, it's going to output some value over here. That's what that question mark is going to represent. It'll actually be a specific value. It could be a number, it could be a variable, but you're going to get something else out that's not necessarily a question mark. Okay, so that's basically function notation. And I'm going to show you some examples of using this function notation, so kind of it makes more sense. So right here, if you actually evaluate or plug something in for x, so it says right here, subbing values for x, that's called function evaluation, and that's what this basically example is right here. So you have a function defined right here, f of x, so again, f parentheses x is f of x is equal to x squared minus 1. Okay, now if you notice down here, the problem would say, what is f of 2 equal to? So just this green right here, what would f of 2 be equal to? So now you're basically substituting this value in for wherever there's an x. So f of 2, this x right here is going to be replaced by a 2, so it's 2 squared minus 1. So instead of x squared minus 1, it's 2 squared minus 1. 2 squared is 4 minus 1 would be 3. So this would be function evaluation. So that's basically using this notation in a problem right here. Okay? I'll make some more example videos of this so you can watch more as well. This is just kind of an easy rundown of what functions are all about. Okay, next we're going to talk about function composition. Function composition basically means you're actually putting a function in as the input for another function. So it says right here, it's f of g of x. Okay, f of g of x. So instead of f of x like we had before, now we're not just inputting an x, we're inputting another function inside that function. So it's a function within a function. It's like inception. Okay, now another way of writing this would be f with a circle, an open circle right here, of g of x. It's the same thing. You do f of g of x. It's the same thing as this. I prefer kind of using this one because this one makes more sense. This is just some notation that someone made up. But just think of that circle as an of. Like it means it's an O for of. So f of g of x. Okay? So we're going to look at an example here. So right here, the blue, f of x equals x plus 1. G of x in green equals x squared. Okay? Then the problem, it says, what is g of f of x? So this time I actually made it where the f of x is the input, and it's being inputted into the g function. So the first thing I'm going to want to do is just use substitution, just plain old substitution. I'm going to, instead of writing f of x in here, I'm just going to write what f of x is equal to. Well, f of x, right here in blue, is equal to x plus 1. So I'm going to replace this right here with x plus 1. That's basically what I did here. So I took this f of x out, put x plus 1 in. So now I have g of x plus 1. So now here, I have to put this in for wherever there's an x in this original. Okay, so I'm going to put x plus 1 wherever this x is. In that case, again, it's really important to always use parentheses in this. I'm going to put this in parentheses right here with the square, and that's how you end up with the answer, x plus 1 quantity squared. Okay, so the g is defined as x squared. This is my new x, so I'm putting that in for x right there. Again, with parentheses, like I did previously with this 2, I put in parentheses. So it's x plus 1 parentheses squared. Okay, so that's a very brief rundown of what functions are all about. One thing I should also add is the x and the y basically make up what domain and range are. So domain is basically any possible x's that you can have, while range is any possible y's that you can have. So that's basically a rundown of what functions are all about. If you have any questions about anything in this video, let me know.